ways if you have 10 random songs in a playlist. So I don't know what song is song 1 and what song is song 10 and what song is song 5. It's irrelevant. There are 10 songs in the playlist. And you're basically shaking the iPhone each time to get a new random song. That's where your 1 in 10 chance comes in. Your 1 in 10 chance comes in. Okay? What happened right here on this particular one, we saw 6 of song 1, 4 of song 2, 5 of song 3, 3 of song 4, 7 of song 5, and so forth and so on. If you add all those frequencies up, it adds up to 50 total songs. How many of them happened exactly 5 times? Those 4. Now that's what a 1 in 10 chance would be, literally. Out of every 50 songs, 5 of them are going to be each song. That's a 1 in 10 chance applied to 50 trials, right? So if it was perfectly 1 in 10, what would this graph look like? What would this graph look like? Right, all these tops would be chopped off and shoved down here to balance out the lows, and it would be 5 across. But here's what actually happens. This is what actually happens. And this is why people were complaining to Apple. They were complaining because they weren't getting enough of a flat curve. They were getting too much of the alternating like this. Well, this has to happen. So where does the 1 in 10 come in? On average over time. That's what those are those 2 or 4 words I was looking for. You have to let the iPod play and play and play and play and keep track of the data if you really want to question the randomness of something. That's why I have you guys do a trial 10 times or 20 times and then collate everything. Because then we see the underlying pattern or lack of pattern. Now if you watch just this track right here, just watch track 1. It's at 5, now it's at 8, now it's at 4, now it's at 5, now it's at 5, now it's at 9, now it's at 9 again, now it's at 6, now it's at 2, now it's at 4, now it's at 4. You see what's happening? What's the average beginning to trend towards? 5. It's beginning to average towards that 10% occurrence. It doesn't mean, it does not mean on any given section you're going to get 10 exact percentage points. It means you're going to get 10 percentage points on average over a long period of time. That's what we suck at, being human. We suck at that. We suck at that. We find little non-random looking sections, go, ooh! And I say, yes, keep going. But I got no time to keep going. I got to check a Facebook message. But you got to keep going. You got to keep looking. You got to keep checking because you got to see if that was just a fluke fluctuation. If you watch these numbers up here, this is what 244 is all about. These numbers. That's a big chunk of 244. When that drops to be very, very, very small, that's when people start taking. Let's see if I can make it very small. Right there. That's pretty small. 5% is what that means. If somebody got a playlist that looks like this, where they saw 11 of Run DMC, but only 1 of Iron Maiden, they would say, dude, this playlist sucks. You're hearing way too much Run DMC, as if you could, which you can't. But that's what they would say. They would say, I want more Iron Maiden and Billy Idol. And I said, well, I do too. But the fact of the matter is, that was a fluke occurrence of 150 song set. All you got to do is keep going and look at the bars. If you kind of blink as it's going by, what are they doing? They're averaging out to 5 across. That's the whole point. Remember the coin from yesterday? Fluctuate, 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 and then stabilize. That's the whole point. You can observe a wicked fluctuation, but that's just one fluctuation amongst a long run of trials. That's what I'm all about with probability. That's what I want you to take. Those of you taking 243, that's what I want you to take with you into 243. It's a long run over average percentage. And that's the point of replicating trials hundreds of times, so you can actually see that. We just collected about 1,000, I want to guess it's 1,200 M&M candy results to see if the colors they claim M&Ms actually are in the bags. But you can't just crack open one bag and count your bag. There's not enough candy in there to see a pattern, or lack thereof. You have to crack open many bags and collate the results. I'll report on Monday as what we came up with. Yeah?
So how do you know if you've done enough trials?
That's a fantastic, you take a 244, right? Yeah, because that's a big question of 244. How large should your sample be? Fantastic. The answer is it varies with what your power and confidence need to be, and that's a loaded question because it's a question that needs a question to answer it. But there are methods you can use to calculate how many times you got it wrong. I give you a minimum though. The reason I used 50 here, the reason I used 50 is because I have 10 songs, each of which are at 10%. 50 times 0.1 is exactly 5, and that number is pretty magical in statistics. There's a lot of things that kind of converge at 5. And that's a minimum. Now, more would definitely be better. One of the students in class last time asked me, well, what if you did 100? I'm like, no problem. So I copied this down and made it 100 and redid the graph. And it evens out even more over 100 trials. But this is a bare minimum that you would use in this situation. You're taking 244, right? There you go. I'll talk you into it. I got 2 more weeks. I got about a week, actually.
I don't need it, but...
You don't need it. If you're ever finding yourself listening to the news and trying to understand the news even more and trying to question it and trying to understand, okay, I now need the tools to understand my world better, 243 and 244 really are those courses. 105 is just the beginning of the 3 of them. So if you ever find yourself, by all means, come join us. 243 first, then 244. That might have sealed the deal against you taking it right there. What, 8 more credits? To hell with you. To hell with you, rule. It's intro to prop stat 1 and 2. This is kind of like intro to prop stat the ground floor and then 1 and 2. That's at least how I kind of designed the course. So anyway, that's what 10% means. Thank you, friends. Thank you so very much. Now, what I need is I need to collect our data from last class. And I also need to open up you guys. Because we have some fun sheets to play with today, if I remember correctly. Where are my 4 quizzes? We'll come back to that. So, we got some data from last time, yes? We had, this was experiment number 4. This was experiment number 4. Experiment number 4. We were rolling 4 dice. No, excuse me, flipping 4 coins. We'll get to the dice today. Oops. That's okay. Flip 4 coins. Okay. So, how will we keep a track? Was it number... It was just the outcomes, right?
Yes.
And we had 5 of them, I think. We had all heads,
Yeah.
all tails.
2 heads, 2 tails.
There we go.
3 heads, 1 tail.
Right? 3 heads, 1 tail. 3 tails, 1 head. Thank you. And then 2 of each.
Yeah.
This reminds me of, and I want to come back to talk about the chickens again, because these are the outcomes you can get if you buy 4 pullets at the store. I told you guys about the hanging upside down trick. I tried that. So if you those of you who weren't here on Monday and you haven't seen the video yet, because the damn thing's still uploading. Apparently if you buy sexed chicks, and you want to check to make sure, because they're only 90% correct. There's only 90% chance they actually did it correctly. If you want to check to make sure they're actually female, I was told this, and this is quote-unquote foolproof. Statisticians use that word, which just means I'm not taking it lightly. Statisticians don't usually say the word foolproof. They say, 95% confident. He said if you grab a pullet, even a couple days old, hang it by its feet, if it just kind of hangs out there and kind of is happy, it's most likely a female. But if it tries to whip around and peck your hand, that's a rooster. So I went home, I was like, let's try it. So I picked up May 2 actually, because we had to take the first May back. Picked her up, she was kind of like, "Bah!" And then she kind of just fell asleep. Like a bat, upside down. I'm like, okay, I bet I'm getting eggs from you. So I put her down, grabbed Fern, picked her up, same thing, then fell asleep. Okay, May's good. Agnes, Agnes, and then what's the last one's name? Gertie. Gertie didn't fall asleep, but she just kind of hung there looking around. Well, I'll be damned. So I'm going to watch him now for 6 months. We'll see what I get. Now that won't prove anything, will it? That won't prove that his method works. But if I get a rooster, it proves that his method doesn't work. And that's an interesting thing mathematically. It's called a proof by counterexample. He tells me something works, I show that it doesn't in one case, that means his claim is invalid. The problem is you can't prove something that way. All you can do is get more and more data supporting it. Does that make sense? Yeah, Mel?
You said, well, what if you, like, hung upside down and you got your chicks, your girls, and then you got a rooster, or you thought it was
I got a rooster.
and then they grew up and it was a chicken and a rooster, so then
That doesn't prove anything either. It just supports his claim, but in order to prove it, I'd have to repeat it infinitely many times.
Okay.
Yeah, counter-proving something is very, very easy. Like if somebody goes, you know what, I bet you if you pour maple syrup in your car, it'll start. Okay. You're wrong. I know I've got a gas tank full of maple syrup. I mean, it's easy to counterprove something. But if someone says something like, you know what, I bet you can power that clock with a potato, and you plug it in and it powers you, you're like, wow, it worked. Which actually it does work. You can actually get a science kit that does that. But that doesn't prove it'll work for every potato. It just proves it worked for your case. You might do it again and it might fail. So the proof by counter example is extraordinarily easy, but proof by example is impossible. because it requires implementing trials to do. So, cool. Does that make sense? Great questions. Thank you. Thank you. Yeah.
Is that what everything is a theory?
Theories generally are, it depends on if it's a mathematical theory or like a scientific theory. The theory of evolution, for example, you don't think you can prove that, it just appears to be true. Like Darwin didn't prove anything, he just said, look at these cool islands where all these birds have different beaks. And their beaks are all different because of what they eat. That seems too cool to be coincidental. So that's where that p-value comes in, that number I showed you, when that gets small. When that gets small, it means you found an association between things. It just doesn't mean that something's causing something else. So Darwin observed that the birds that have the beaks that kind of cross over eat a very special kind of seed that requires them to have that beak that pops the seed open. Where a woodpecker has this beak that's shaped like a nail because it has to drill holes through the tree. So his theory was these animals adapt to their environments. You can't prove that. All you can do is observe it. So a theory in science is unprovable but observable. A theorem in mathematics is actually provable. Pythagorean theorem, you can prove that. I mean, you can actually sit down mathematically and I can draw pictures and we can say, okay, this and this is a right angle, then this and this, and I make a square out of this. And you can actually, it's like point A to point B and it's a path. That's why theorems in mathematics tend to be a little more rigorous than theories in science. But I like the theories in science too. I mean, you know, I like to think that gravity is because of the more masses something is, the more gravity it has. The whole gravitational constant idea. So, does that kind of answer your question, Jeremiah? It's a great question.
It's like a theory and a theorem.
Yeah, kind of. They have the same idea in that it's an overarching belief. It's just how much, because you've heard of theories being overturned.
Right.
That's when you find a counterexample.
Yeah.
Like, I bet I can fly! Okay, theory's gone. Yeah, that kind of thing, right? So, good, thank you. What were our results, friends? You got, somebody has this, right? Because I didn't write them down.
16.
Chelsea, you did 16?
16, 8, and then the 2 and 2 is 63.
63, love it.
And then the 3 heads, 1 tail is 55,
50.
and then 3 tails and 1 head is 48.
All right, and what did I ask you guys to go home and do? Get percentages?
Calculate empirical and theoretical.
Love it! Thank you, Mel. So, in other words, we had to add these up. Oh, I remember this, because Rob ruined my day. This summed to 190, right? And I was so excited that Rob reminded me there were 220 trials. Not 190, because a couple more people had walked in. It's all right, brother. I needed to be shut down. It's good. So, based on that 190, what do we get percentage-wise? What is this as a percent?
8%.
That's 8%. Out of 190 is 8%. Thank you. What's the, this is going to be exactly half, isn't it? 4%? Is that fair? I heard no. No, that's fair. Oh, okay, I thought I heard a no. Okay, good. 55 out of 190, I'm not going to do yet. I will do 48, though, because that should be, I'm guessing, 24%. 25 with rounding. There we go. This is going to be 63 out of 190. I'm going to call that 32%. 33%. And I'm going to leave this one for last so I can add up 12 and 25, 37, 70, 30%? 29%, there we go. And notice, somebody brought up something very cool last time about these don't add to 100%, do they? Oh, they do! No, they don't. We're missing a 1%, aren't we? 8 and 4 is 12, 31, right? 56.
It could be a rounding error.
It guaranteed is a rounding error somewhere. And that's okay. Rounding errors are totally fine. It doesn't add to 100%. Rounding errors happen. FYI, and this is probably not important to you, it might be important to you at some point in your lives, some of these numbers can be gotten pretty rapidly once you guys have told me one of them. Like as soon as I knew this was 8%, how did I know that was 4%? Because 8 is half of 16. And that's why I like jumping down to this one next. Because 48 is 3 times 16. So that means this one has to be 3 times that. I said 24, but with rounding it was 25. And then 63 is almost 64. Almost 64. And 64 is 8 times this or 4 times that. So you can kind of be tricky mathematically. I wanted to avoid 55 over 190 because I couldn't do it in my head very quickly. I'm sorry, take care of it. Oh my goodness. Fair? Beautiful? Gorgeous. So the most likely outcome is 2 and 2. Most likely outcome is 2 and 2. Least likely appears to be all tails. Next is all heads. These are pretty close to each other. And it looks like 29 and 25 are pretty close too. That was empirical, yes? How about theoretical? Anybody do theoretical? It's okay if you did. It's okay if you did.
You mean the listing it out?
Yes, we have to list them all out, wouldn't we? So, what's one outcome, theoretically, for flipping 4 coins? Well, you've got 5 events, but this isn't all the outcomes. For example, there's only one way to get all heads. That's heads, 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 right? There's only one way to get all tails, and that's tails, 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 tails. How many ways can you get 3 heads and a tail? Careful, there's 4 ways, right? There's 3 heads and a tail. There's 2 heads, a tail, and then heads. There's a head, a tail, and 2 heads. And last but not least, start with the tails and end up with the 3 heads. Does that make sense? This was what your third project was all about, was keeping track of all this stuff. So yeah, and that might make sense. This was about 4 times as likely as this. Well look, there are 4 times as many ways for that to happen. That makes sense, doesn't it? How about 3 tails and 1 head? Say that again.
Same thing.
Yes, it is. Just switch the tails and the heads. You can go tails, 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 heads. Tails, tails, heads, tails. Tails, heads, tails, tails. Or heads, tails, tails, tails. So, in other words, these two should be pretty close to each other percentage-wise, because they have the same number of outcomes. Now this one, for us, was the most common, yes? Most common. How many ways can that happen? I hear a vote for 6, I hear a vote for 8, let's go with 7! No, I'm kidding. Let's list them out, yes? Let's list them. Give me one. Give me one. Let's just average it. No, I'm kidding.
Tails, heads, heads, tails, heads.
Tails, heads, tails, heads. Can I reverse that one? Heads, tails, heads, tails?
Yeah. Then
Heads,
tails, tails,
heads,
heads, heads.
Tails, heads, heads, tails. Is that what I heard? I think. That's what I heard. Whether or not you said it or not. And reverse that one? Heads, tails, tails, heads.
Then you have tails, tails, heads, heads.
Ooh!
Heads, tails,
Tails, tails, heads, heads. Heads, heads, tails, tails. Any more? There's 6. Janelle said 6. Mike said 8. Do we have any more? Got it. Got that one. Well, you know what? Actually, before we go any further, we know how many total outcomes there should be for the entire experiment, right? How many? 16. Remember our pattern? When we flip 1 coin, there are 2 outcomes. When we flip 2 coins, there are 4. 3 coins, there were 8. 4 coins, 2 times 2 times 2 times 2, that's 16, yes? And there are 16 on the board, we're done. We can stop looking. We know we're done. If we flip 5 coins, which I won't make you do, we'd have 32. That number might ring a bell from your last project. I didn't have you flip 5 coins, but I had you guess the 5-question true and false quiz. Aha! All right, good. Now, on average, let's come back to that. Let's look at the theoretical probabilities first. So what's the theoretical probability of getting all heads? 1 out of 16. It's 1 out of the 16. Well, 1 out of 8, that's about 6%, which is not that far from 8%. If you divide that out, it's going to be, I think it's going to be 6.25%, I think. Because an 8 is 12. Yeah, 6.25%. That's not that bad. And guess what? What's the chance of all tails, theoretically? Same. Now this is kind of cute. This is under just as much as that one's over. So again, that won't always be that way. That'll correct itself over time. It'll hover to that 6%. How about the chance of 3 heads and a tail? It's 1 in 4. It's 4 in 16, right? Or 1/4. It's 4 in 16. 1, 2, 3, or 1, 2, 3, 4 out of the 16, which is the same as this one, right? This one actually hit it almost perfectly. This one's a little bit above, which means this one's a little too small by number, by percentage. Because this one should be 6 out of 16, correct? 6 out of 16, let's see, this is 24, it's 25%. If I had half of that, 37.5%. Yeah, we're down about 3 percentage points on that one. But again, that's just flukishness because we stop when we stop. We have to keep going to see those probabilities kick in infinitely over time on average. But we're not that far from them, are we? We're not that far. On average, how many should we have gotten? On average, how many heads should we have gotten? On average. Okay. Want to crank it?
50%.
50% of them, so give me a number.
Isn't it when you, we talked about this, when you get a tail, it's a 0.5% of that?
Nice! Every additional coin you flip, you pick up half a head and half a tail on average. For every one coin on average to the long term contributes half a head and half a tail. So with one coin, you average half a head or half a tail. With 2 coins, you average 1 head, 1 tail. With 3 coins, you average 1.5 heads and 1.5 tails. With 4 coins, you average 2 heads and 2 tails. The most likely outcome, the average outcome. With 5 coins, you would average. With 6 coins, and those are going to be the most likely outcomes every single time. That the middle probabilities are going to be the ones that have the highest outcomes for flipping a coin, because, of course, it's equally likely heads and tails. This is where it gets interesting with the chickens. Do you know which of those? Now, if we change heads and tails to girls and boys, let's change that to girls and boys. You don't do this in your notes if you don't want to. We make this, what's this boy symbol? That's the arrow, right? All boys. Is girls the cross down?
Yes.
Okay, all girls. So that's all. I got 4 girls, egg-laying girls. I got 4 non-egg-laying boys. This would be 3 boys, 1 girl, 3 girls, 1 boy, and 2 of each. Do you know, in the chicken world, which one of those is the most likely outcome? It's not 50-50. That's what makes it interesting. It would be 50-50. This brings up a good point. I told you the story about Lava Ridge, yes? If my wife originally wanted to get our chicks from Lava Ridge School.
Oh, yeah.
FYI, not to brag about my wife, she's freaking awesome. She just won a $170,000 grant from the state and the feds. They're going to put 45 kilowatts of solar collecting power on Lava Ridge School. It'll be the only old school in Bend that has PV cells. It'll offset like 30 or 40% of their power bill.
That's really cool.
Warren Miller already has them, but they had to because it was a new school, and there's some other school that has them too because they're new. But it's the first school in town because my wife's a freaking rock star. Hey, baby. But she's not going to pick a chickens from Lava Ridge. Love you. Because she said, let's go in and let's let them raise their chicks, and we'll take 4 home from them. And I said, God, no! Because that means on average we're going to get 2 and 2 because it is a coin flip when you just lay baby eggs and let them hatch. I'm assuming chickens, like people, have half girls and half boys. When you go to the feed store, though, to buy the little day-olds or the 2-day-olds, they've been sexed. Which means when you go into the pullet bin, you know, these are the white Leghorn California pullets. These are the molten Java pullets. These are the Sussex, that's what Fern is. Sussex. I bought it because Sussex is a county in Delaware. These are the Sussex pullets. They have been identified as female by somebody who knows how to do that thing. I guess they look at the skirt and look. 90% chance a pullet is female, according to everybody I've talked to. 90% chance. So let me ask you kind of an advanced question here. What's the chance if you buy 4 pullets? This is the chance you're going to get 4 boys if you're flipping coins to decide if it's 1 in 16. But if there's a 90% chance of a female, which means there's a 10% chance of a male, right? 10% chance of a male. Can anybody figure out what the chance of getting all boys is? Pretty good or pretty bad?
Bad.
Very, very bad. It probably isn't going to happen, but what is the chance of it happening?
6%.
Where'd 0.6% come from?
Okay, so I took 1/16 and then times it by 0.1 because the boys is only a 1 out of 10 chance.
Good.
So I got 0.006, so that's 0.6.
Now take away the 1/16 because we can't even use that 1/16. We're not allowed to. That's a coin flip. You ready for this? Janelle, thank you for giving me an idea how to answer this question. May I over here? Thank you for this. Thank you, sister. Let's draw a tree diagram. I know you guys like them. No, the reason I bring this up is I taught the guy at High Desert Ranch and Home this. And he was like, this is like the coolest thing I've ever seen. I'm like, of course it is, because it's probability. It's awesome. But he's like, yes, but people always buy these birds 4 at a time. Why? Bend City Code. That's the maximum number of birds you can have on a certain square footage of lot, or per certain square footage. People often buy them 4 at a time. So I told him, you can tell people when they buy 4 birds, there's a 1 in 3 chance you've got a rooster in your box. What? How do you know that? And I sat down with a piece of paper, drew the tree diagrams. So here we go, you ready? Here's Max at the feed store. Little blue dot. First bird is either going to be a boy or a girl. What's the chance it's a boy? 1/10. Not a very good chance it's a boy. 10%. 10% of the time it's a boy. 90% of the time it's a girl. Okay? Puts the bird in the box. Doesn't go home yet because we're buying 4 birds. Yes? So then he buys the second bird. Okay? Second bird. It could either be a boy or a girl. What's the chance the second one's a boy?
1/10.
10%. That's not changing. Now, some of you might claim it should be changing because you're pulling the birds out of the bin. Have you ever been in the feed stores when they're selling day-olds? It is chaos. Hundreds and hundreds of little peeps running around pooping on everything. It's adorable, actually. So it's still 10%. It's still 10% and 90%. It's going to be that way for all the birds. Now, I'd like to stop right here temporarily. What is the chance at this point Max has grabbed 2 boys? Can you see that outcome? Do you see where that outcome is? Getting a boy and then getting a boy again? It's like flipping heads then flipping heads again. You have to first land on this branch, and then you have to land on this branch. So this would be the outcome of 2 boys, correct? So how often would that happen? If it's 10% likely to get a boy the first time, and then 10% likely to get a boy the second time, how likely would it be to get both boys? It's 1%. It's 1 in 100. Because first, you have to first be in this 10% and then again be in this 10%. That's 10% of 10%. You're only going to get 2 boys 1/100th of the time, which means you shouldn't get 2 boys. That should only happen 1 in 100 times
On average.
on average. Which means, if I send Max and 99 of his friends into those stores, over time, one of those kids come up with 2 roosters. It's got to happen, probability-wise. And if you do, most likely they'll let you take them back and get new birds next year. Or you can put them on Craigslist, or you can make soup out of them, whatever. Okay? Not to be too crass. Okay? What's the chance of 2 girls? Sorry for all the vegetarians in the room, my apologies. What's the chance of 2 girls? 90% chance for the first girl, and then you have to hit another 90% chance for the second girl. What's that end up being? 45%. Careful.
81%.
81%, right? 90% of 90%. We're multiplying these bad boys. You first have to be in this 90%, and then of that 90%, only 90% more, which ends up being 81%. It's getting harder to get all girls with every single bird he picks up. Because every time he picks a bird up, he's flipping a coin, isn't he? But the coin lands 90-10 instead of 50-50. It's weighted heavily for the girls, but every time he goes into that bin, the first thing I'm thinking of is, if I have to get rid of a rooster, how am I going to do it? Because the first thing, he's already named the damn things. He had the names before he went to the store. I'm effed. You can't kill something you named. Fair? Say, well, okay.
Yeah.
Very good, very good. So there's a 1% chance. There's a 1% chance that they're both boys. There's an 81% chance they're both girls. That's 82% altogether, right? The remaining 18% has to be one of each, correct? Now look, check the math. 10% of 90% is 9. And 90% of 10% is also 9%. There's your other 18% right here. That's like heads, tails, tails, heads. Remember that one? Remember that outcome? Heads, tails, tails, heads? Heads, tails, tails, heads was a double outcome. It was twice as likely as all heads or all tails. Now the reason it was double likely is because it was 50% for each of those. But when it shifts, this happens 1 in 100 times on average over time. These happen 18% of the time. This one happens 81% of the time. What's the most common outcome? Both girls. Thankfully, because usually when you go to buy pullets, you want girls because you want eggs. That's kind of the point, right? Is that fair? Is that fair? Let's go one more set of branches, then I'll complete the 4-girl branch set. After break, we can analyze why I told the guy at the feed store a 1 in 3 chance of a rooster, and you'll hopefully believe why I said 1 in 3. Rob, what's on your mind? Just take it all in. Actually, you know what? Take 5 right now. You guys take 5, I'll let the battery cool down a little bit, it's almost dead. And then I'll complete the tree diagram and we'll answer my question. If Max buys 4 birds, what's the most likely outcome? And how dare I tell the guy it was a 1 in 3 chance of a rooster?
I don't need a rooster to get headed.
Nope! You need a rooster.